This is Intro to Proofs. We're starting section 4.1 today. So I'm recording this on April 3rd. So in preview activity 1, so again, I know I said this a lot of times, but you should really attempt preview activities before watching these videos. So in preview activity 1, we're given 6 sets. A, B, C, and D are all subsets of the integers because they start with the B, C, and D start with the integers, and then S and T are subsets of the real numbers. So 1, write elements of the set B using the roster method. Okay. So elements of the set B using the roster method. Well, what are the x squareds that are less than 12? -3, -2, -1. I got it. Have a bracket. 0, 1, 2, 3. All right. Part B. Is the set A equal to B? Explain. Yes. Why? Because all the elements in A are in B, and all the elements in B are in A. So they each contain each other, so they're equal. Okay. Part C. Is A a subset of B? Yes. Yes, A is a subset of B. Because everything that's in A is also in B. Here, let's see it. Everything that's in A is in B, so A is a subset of B. A subset means all of your elements, excuse me, all of your elements are in the other set. Okay, is A a proper subset? No, it's not proper subset. In order to be a proper subset, you have to not be equal to it. Okay, is B a subset of A? Yes, because everything in B is also in A. All right, moving on to number 2. Write the elements of the set C and D using the roster method. Okay, so with C, I've got x in the integer such that 2x minus 3 is less than or equal to 7. Okay, well, what's the biggest x I can get? So if x is 3, it'd be 6 minus 3 is 3. If x is 5, then, okay, so then 5 works, because 2x minus 3 is less than or equal to 7, because that's 2 times 5 is 10, minus 3 is 7. And then 4, 3, 2, 1, 0, -1, -2. I'm writing them kind of backwards the way we normally write them, but it's okay, because it's just the set. The order doesn't matter. All right. Okay, C and then D. Is the set equal to set D? No, it's not equal to set D. Why? Because C has things that are not true for D. So for instance, like a -6, there's a -6 in here, but there's not a -6 in D. So no. All right, C. Is C a subset of D? No. Because C contains something that's not in D. Okay, is D a subset of C? Yes. Everything that's in D is from like 5 to -5. So everything that's in D is also in this set right here. Okay, is D a proper set of C? Yes. Because not only is D a subset, but it's not equal to that set. All right, moving on to 3. Is it possible to write the elements of the sets S and T using the roster method? No. There's too many numbers. Because you could write, for instance, 5 is in there, and also 4.9, and also 4.99, and also 4.999, and also 4.99999. And you can do that, and that's just one part of it. So you can do that forever, and you never make it to the Boolean set. Is S a subset of T? No, because S there's like, you can have like negative 100, and that's true, but it's not true here. So C, is S, oh, they're not equal, and S is not a subset of T, okay? And then is T a subset of S? Yes. Okay, let's write those two subsets on the number line. That might help you visualize them. So one of them is from here's -5, and here's +5. And so the set S is including this number and going all the way. That's X. And set T, just imagine it on that line. Set T is that number, and all there. So, oh, you can't see that, sorry. So if you imagine S being on the number line and T being on the number line, then S goes from -5, I think I'm doing this backwards, +5, yeah, I wrote it all the way backwards, come on. +5, that way, that's S. Okay, so T fits inside of S, so it's a subset, but S does not fit inside of T. Okay, 3, so T is a subset of S, yes. T is also a proper subset of S because T is not equal to S. Okay, the formal definition of subset states that X is a subset of Y, provided that for all X in U, if X is in X, then X is in Y. Uses formal definition to complete the following sentence in English. The set X is not a subset of Y, provided that, okay. Let's see. X is not a subset of Y. So you got to negate the sentence. If instead of for all things in X, they're also in Y. Instead of that, we're going to say there exists an element of X such that X is not an element of Y. That's how you know it's not a subset. It's not a subset if there's something in here that's not in there. That concludes preview activity 1.